Right, thank you all for hanging around, and I'm going to talk just for a little while on something that I've been spending a little while playing with over the last couple of years, specifically ClickHouse. This is me. That's how you can get hold of me in real life. And first, a bit of background about what I've been doing with ClickHouse. Back in June 2018, I started working on a project for displaying statistics about the volume of DNS queries going through DNS servers operated by ICANN. ICANN, the Internet Commission on Assigned Names and Numbers, runs several DNS services, the main one of which they've recently started calling IMRS, short for the ICANN Managed Root Server, is one of the 13 DNS root servers. It's the DNS root server which I fondly think of as being formerly known as LRoot. This system is actually about 250 individual servers worldwide. It serves currently in the region of 17 billion queries a day. And each query and response is logged into a central ClickHouse cluster at ICANN, running on currently 6, though the system was originally designed for 4 servers. ClickHouse has become somewhat popular for this kind of application within the DNS community over the last few years. As you can see, ICANN are swallowing an interesting number of queries every day on a relatively few servers. The total volume that's coming into them is about 0.5 terabyte every day. Cloudflare operate a rather larger cluster, which I believe is doing something similar. Cloudflare recently broke through the 1 trillion queries a day marker. I'm not going to talk any more about this particular system because that, to be frank, is another talk. But just before I do, I'll mention that if any of you have ever had to try and do bar charts in Grafana, you'll have discovered it's not easy. You might want to talk to me afterwards, particularly if you're using non-time series data. However, back to ClickHouse. So, where's it come from? Well, ClickHouse comes from Yandex. Yandex, if you don't know, it is basically Russia's Google. Its origins go back to 2008, and it's used internally in the Yandex metrics system. It's grown over the years and was formerly open sourced under an Apache 2.0 license in 2016. So what is it? It's a column-oriented database management system, and it's designed for OLAP, online and analytical processing applications. Now, one of the interesting lists on the ClickHouse website is a list of, for those of us not familiar with it, online analytical processing. What characterizes it? And this list gives you is actually a pretty good guide for the kind of applications where you might want to consider using ClickHouse. Specifically, data is added to the database but not modified. It is kind of possible to modify data on ClickHouse. It's pretty new, and you really don't want to be doing it on any kind of basis other than occasional small changes. The vast majority of requests are for read access. And for reads, you're extracting a large number of rows from the database, but only usually a small subset of the available columns. Typically, these databases have only a few tables of what I'll call the raw data with lots of columns, of which you're interested in a few at a time. And this is one of the reasons that a column-oriented database is faster for these kind of applications, because when you're doing a query, it only needs to read data from the relevant columns, And because a column-oriented database where data is stored in separate files for each column, that means it can just ignore large swathes of the data that it might otherwise have to move through in a row-oriented database. Secondly, data is updated in fairly large batches, typically over 1,000 rows at a time. You require high throughput when processing a single query. You don't need transactions because basically what you're mostly doing is reading or just adding new data. And finally, a query result is going to be significantly smaller than the source data. And so the query result from a query can probably fit into a single server's RAM. If this sounds like your application, then maybe you should have a look at ClickHouse. At the start of the project I was alluding to, we evaluated several different databases. It was a while ago now, and I cannot remember the details about the other ones particularly. So I'm not in the business here of doing direct comparisons against, say, Elasticsearch or Hadoop. But I am going to come back to talking about why we picked ClickHouse and why I like it. So another thing about ClickHouse, yes, it really is open source. Here's its GitHub page. You can open issues there. I have done several, and they read them and they respond to them and they fix them as well. There's also a very helpful Google Groups forum. If you get stuck, there is help. Oh, and one more thing. Not only is it open source, did I mention it's written in C++? This is rather nice for me personally as well, and I expect for a lot of you, because of course, if there's a bit of functionality in there that you really, really need, or indeed you just want to understand something of what's going on inside, you can try. For this talk, I have actually ended up building ClickHouse from source. The reasons for this is quite simply that, please mind my clock. The reason for this is quite simply, I was originally planning to do this talk on my laptop, but my laptop's webcam isn't so hot. My desktop has a rather better system. However, my desktop's a bit elderly. It's a 10-year-old Phenom-based system. And the binaries that ClickHouse supply all assume your processor supports SSE 4.2, and mine doesn't. So I've had to build my own, which was interesting. You clone that repository and you get no less than 70 or so sub-repositories out of that, all of which need to get built. It basically brings in all its dependent libraries. However, so what do I like about ClickHouse? Well, first of all, modulo my experience having to build it on my particular out-of-the-arc system is that actually it's easy to install and play with. I'm normally using Linux-based, typically Debian or Ubuntu systems at work. Installing from Ubuntu was just a simple case of apt install ClickHouse server and ClickHouse client. The data that I'm dealing with is structured. It's very much columns of individual items, traditional SQL database stuff. So you get something that is close enough to a traditional SQL database that you feel reasonably at home. Import. If you're dealing with large amounts of data, one of the crucial things you face is simply the import speed. Are you actually going to be able to suck this data into the database fast enough to keep up with your incoming data flow? This was a problem on a couple of the databases we tried, but has been no problem with ClickHouse easily manages what we throw at it, which is about 200,000 records every second. And you get fast search as well. For the reasons that some of the reasons I've covered already, but it's pretty fast. It's fast even when you take the column database into account. Another absolutely crucial feature that we require is import time aggregation. And I'm going to talk more about this in a moment. Simply, although the database is fast, we do still want to be able to do our Grafana plots in a reasonable length of time. And when you're chewing through billions of records, no matter how fast your database is, this is going to take time. So in fact, nearly all the graphs in our system are backed by specialist aggregations where we're distilling down the captured raw data into summaries, typically individual records of 5-minute summaries. I mentioned we're running this on a cluster, and again, I'm going to talk about how this works in practice. The clustering, you spread your database over the cluster using a particular table type, a distributed table type. And again, I'm going to come back to that in a moment. And finally, ClickHouse also supports table replication across the cluster, so that you can have multiple copies of the same table in your cluster, so that one will effectively function as a backup should you need it. We, in fact, do not use this, so I'm not going to talk about it in this talk, but it's there if you need it. Anyway, let's have a look at a table. And this is a table taken from the open source version of the system that I've just shown you. This is the main table. We have one main table into which all our raw data goes. And as you can see, this is the start of the definition. It looks reasonably comfortingly like SQL. A couple of notes: there's no Boolean type. And by default, columns are not nullable, because that implies a small storage and processing overhead. ClickHouse can do nullable columns, but you have to explicitly declare them as such. If I move on now to the other end of this table definition, and as you can see, there's quite a lot of columns. It's the bottom of this that we start getting into interesting and non-standard SQL territory. You'll notice, first of all, we're declaring an engine. This is the table engine used to store this table. And the merge tree is ClickHouse's standard table format. There are other table formats. I've already mentioned the distributed ones. There's some interesting other ones as well. You'll notice the next thing we specify is partition. ClickHouse partitions data when by default, if you have a time stamp for your records, by default into monthly partitions. The effect of this is that individual data files on the disk are grouped into monthly data. So you get a fresh file for every month. With the volume of data we're handling, we found that actually we needed a finer granulation, because when you, as well as not being able to update data, you can't readily delete it. And your easy option is simply just to drop an entire partition at once. So we're partitioning into weekly data. Order by specifies the table key. Sample. We're not using this. I put it in there just in case we do in the future. ClickHouse has the option of doing sample queries. If you really want to speed up your query and you're not fussed about a completely accurate result, you can run a query and sample, say, 1 in every 10 records. Now, I mentioned earlier, talk about aggregating data. The way you go about this is create a separate table. And here I'm creating, you'll notice I'm creating it in a different database. And incidentally, I'm naming my tables shard for reasons that I'll come to in a moment. But basically, this is data on a particular machine in the cluster. Notice here also that ClickHouse will let you have nested columns, so you can have multiple values in a column. But the main difference I want you to notice here is the engine is now a summing merge tree. A summing merge tree is a variant of a merge tree table where any item ending in count will get summed automatically. The records, you put raw records into this table, and the table engine crunches them down for every record where you have a matching date and date time, and indeed node ID here. All the other records will be agglomerated into one record with items named count being summed. So what this table is doing is this is giving me a count of the total number of queries in my particular time frame, and also counts for every individual opcode and type. Those are just DNS numbers, categories within that type. So how does data get into this table to get summed? Well, this is where I mentioned that it relies on the process of creating a materialized view. This is a view which has an actual physical data backing. So what we're doing here is from the main table, every time an insert happens into the main table, this select is run. You'll notice there's a where clause in there as well, because specifically here we're picking out just DNS queries where there was a query. Yes, you can, under some circumstances, have queries where you miss the query, and but you've got the response. So here we're collecting data from the main table when it's inserted, and we're selecting the items we need for the aggregated table and pushing them into the aggregated table. I mentioned also earlier as well distributing data across a cluster. In the server configuration, which is an XML process, XML file based, you define a cluster as being essentially a collection of individuals, so a named collection of individual servers. What I'm doing here on each server, I'm creating another table. The physical table I've called query response shard. I'm calling this table query response, and you'll notice it's got exactly the same schema as the main table, except the engine is the distributed engine. And here I'm telling the engine to distribute queries or inserts across a cluster called DSV. And inside that cluster, I want to query or insert into a table in the DSV database and the table called query response shard, which is the one we defined earlier. The final parameter in there controls how new data is inserted, how when you're inserting, if you're inserting data directly into the distributed table, how that data is distributed across the cluster. RAND basically assigns hosts randomly for each individual record that you put in. And so in our case, where we have a group of 6 identically configured and specified servers, we're spreading the data equally across all the servers. If your servers are of different specifications, you can assign weights to each server to encourage data to go to one more than the other. So let's just have a quick look at how this works in practice, about how you do this from the command line. So give me a moment to pick a window, and here we go. Right, first, you'll notice here I have, in that list of files, I have a 13 gigabyte file, talk.tsv. This is a tab-separated value file, which contains the data that I've imported for the basis of this talk. You'll notice that it took 17 minutes, 17 and a half minutes on my rather old desktop with spinning Rust to import the data. I had it planned to do a live import. And in fact, on my laptop, which has an SSD and is a 2016 Intel Core 5, that import took 2.5 minutes. However, my desktop, as I said, has got a nicer camera, so we're doing my desktop. So we've got some data in there. Let's try a couple of queries. Fire up a database client. And first of all, let's see how many records I have in my main data file. Let's count them. Right, I have getting on for 48 million individual records. And what about the aggregated file that I talked about earlier? How many records are we going to find in there? Well, I'll come back to that in a moment. But first, what I want to do is show that you get the same answer out of both of them. Now, specifically, you'll remember that in the aggregated table, we're only importing queries. So the first thing I want to find out is the total count of just queries we have in the raw data. So let's repeat the previous query, but this time focus only on data where there is a query. So we have, again, 47,794 rows to deal with. If I go over to the aggregated table, I'm going to have to run a slightly different query to get the same answer. But I do at least get the same answer. Now let's try looking at a query with, first on the raw table, with some further selection. This time I'm actually looking for so-called Quad A or IPv6 queries. And let's do the same thing from the aggregation. Again, this query is a bit more complicated. The array join we use to essentially promote the nested fields into a place where we can query them. And again, we get the same answer, but we get it a lot quicker. And this is generally the experience we have. But surprise, surprise, the number of records that you have to pile through being a lot less, the query results come back a lot quicker. And finally, just as a demonstration of going through raw data where there is really no alternative, you can't really aggregate a data based on a query name, i.e. the name that's being looked up in a DNS query. But you'll see there, even on this rather elderly and not very spectacular hardware, ClickHouse manages to work through a lot of rows in not a great deal of time. So I hope I have managed to give you something of a flavor of ClickHouse. That's all I really wanted to attend here. A few resources for you for further reading. That was all very quick. Altinity is, incidentally, a consultancy that specializes in ClickHouse, and I found their website extremely useful. The final link, if you want to look more closely at the project that I've been showing you, the final link is a link to that project. It got open sourced last week. And you can look in more detail at ClickHouse, the ClickHouse schema, and how it and the connection into Grafana and so forth works. Anyway, thank you all very much indeed for listening, and I'll wish you a good afternoon. So I will also be heading over to level 2 in Remo and having a little chat with Natalia. And I hope I may see some of you there. So thanks and good afternoon to you all.